Okay. Set of ordered pairs is an input and an output, usually x comma y. We don't really use that word very often because usually we're talking about functions. But not all relations are functions. Go with the picture here, right? Venn diagram. Every function is a relation, but not every relation is a function. It's kind of the squares and rectangles thing, right? Every square is a rectangle, but not every rectangle is a square. So in a minute we'll see about what makes it fit the special function category, although I think you already know it. Domain and range we talked about yesterday. That's the x's for the domain, the y for the range. Relations can be described by, so you're familiar with all these things. You've seen graphs, you've seen equations, you've seen a list of ordered pairs. Mapping diagram you've probably seen, although you may not know that's what it's called. A table you've certainly seen. And a written rule, that would be like something in words, like y is twice of x or something like that. So we don't see the written rule very often. All right, this stuff is, I don't like the way that phrases that, so just mark all that out. I don't have much space, but I want to talk about the vending machines in terms of functions, because that's what makes the most sense to me. So we got a vending machine with buttons on it, and the buttons correspond to certain drinks. So we'll just say the Coke and a Dr. Pepper. So this is clearly not a school vending machine. You can't get those sugary drinks here, unless you're in the teacher's lounge. They let us make poor decisions, but not you. Let's say you push button 1, you get a Coke. Let's say you push button 2, you get a Coke. And you push button 3, you get a Dr. Pepper. You've seen these kind of vending machines where there are like 2 buttons that will give you the same drink. I don't know if we know this yet, but does that seem like a functioning vending machine to you? Maybe I should give another example. Let's look at, I made that too big. Let's do one right here. We'll say button 1 maps to a Coke. Push button 1, you get a Coke out. Great. Push button 2. It goes to Coke and Dr. Pepper. It's like that's great if that happens to you, right? You hit one button, you get 2 drinks, good for you. But that's not a functioning vending machine. So we'd say that's not a function, because you don't know what you're going to get. For a functioning vending machine, you know what you're going to get. You get one thing, you know what you're going to get. Like there's one output for each input. And maybe more than one button leads to the same drink. That's fine, you know what you're going to get. In fact, if you map some of our vending machines, they have 10 buttons and you always get water, right? You seen those down there? That's a functioning vending machine. You know what you're going to get. So it's a weird one maybe, but it's still a function. So if it maps to one drink, you're good. If one button maps to 2 outputs, it's like that doesn't work as a vending machine. And then there's a special type of vending machine. Let's say 1 goes to Coke, our special type of function. 2 goes to Dr. Pepper. And 3 goes to, I don't know, what else do you want to get from a vending machine? What's your favorite soft drink? Sprite it is. So that's definitely a function, because you know what you're going to get. But because each output came from exactly one input, we call it a one-to-one function. Another way to say that is you could go backwards, meaning if someone's standing there with a Coke, you know what button they pushed. If someone's standing there with a Dr. Pepper, you know what button they pushed. If someone's standing there with a Sprite, you know what button they pushed. It's one-to-one. If you were standing next to this vending machine, if someone's standing there with a Coke, you wouldn't know which button they pushed. It's not one-to-one. Okay, so there's sort of two things going on here. Is it a function and is it one-to-one? It's a function if it works, like you know what you're going to get. That's part of the easy one. It's one-to-one if you could go backwards and they're mapped one-to-one and you could tell what button was pushed. So let's see if we can extend that to ordered pairs here. So 6 is the input, 4 is the output. So if we push button 6, we get a 4 out. If we push button 1, we get a -5 out. And if we push button 6, we get a 1 out. Is that a function? No. Why not? Yeah, we got 6 going to 4 and 6 going to 1. That's not a function. Is it one-to-one? That doesn't even matter, because if it's not a function, it can't be one-to-one. So I'm going to say like not applicable. It doesn't even matter. The domain is the x's, so that would be 6 and 1. The range is the y's, so that would be 4 and -5 and 1. I listed them in order. Some people, that annoys them, they want to put them, or excuse me, I put them in the order that I saw them. Other people think that looks funny and they want to put them in numerical order. So they'll sort of rearrange them in their head and put them in numerical order, and that's fine. It doesn't matter. Okay, the second one. Is that a function? Yeah. Push button 1, I get a 2. Push button 2, I get a 4. Push button 3, I get a 4. So yeah, that's a function. Is it one-to-one? No. Because two things lead to a 4. So if someone's standing there with the 4 drink that they got out of the machine, you don't know what button they pushed, you couldn't go backwards. Domain is just the list of x's, 1, 2, and 3. Range is the list of y's, 2 and 4. And you don't have to like relist it. 4 happens twice, but you don't need to list it twice, because this is just the list of things that show up. All right, you try those next two. All right, Audrey, how about that third one? Is that a function?
Yes.
Yes, it is. Haley, is that a cheating? Figure out where Haley is. Where's Haley? Okay, thank you. Haley, is it one-to-one? No, why not? Yep, there's 2 -1s. Oh, there's also 2 zeros, but what you said was also correct. Giovanni, how about, yes?
How is that a function if there's 2 1s in the x value?
Okay, that is a tricky one. How is it a function if there's 2 1s in the x values? Well, look at what the y values are. Okay, so that's a tricky one because you think you learn a shortcut. It's like, oh, let me just look for repeating x values, and that normally works, but this one is kind of a trick. And which means, Haley, your reason for it being not one-to-one is not that there's 2 -1s, because this is just the same point. It's because there's 2 zeros. So it's not one-to-one, but it's not the -1 that's a problem, it's the 0 that's a problem. Giovanni, how about the domain? 1, 2, 3. And Dionese, the range? Yeah. And this is pretty easy. The last one is yes and yes, and you can list the x's and y's. I'm going to speed things up a little bit. Vertical line test. You familiar with the vertical line test?
Yes.
Okay, that's the one where you put a vertical line or vertical pencil, and if your vertical line hits 2 points at once, then it's not a function. Because if it hits 2 things at once, that means there's one input button. Maybe that's 2, 4, and maybe that's 2, -1. So you don't know what you're getting. You push the 2 button, and you're getting a 4 and a -1. That doesn't work. So I think everyone knows the vertical line test. They just don't always understand the connection between the vertical line test and the input-output thing. Okay. State the domain and range of each relation. If you can read this, then determine whether each relation is a function. If it's a function, determine if it's one-to-one. All right, I'm not doing that one. I can't read that. 18 is pretty blurry too, but the arrows alone can let me figure out. Is that a function? Uh-oh. Is it a function?
Yes.
If I hit a button, do I know what I'm going to get?
No. Yes. Oh wait, yeah.
Yeah. It's a function. Any button I push, I'm going to get exactly one output. In some ways, you can tell it's a function just by looking at the arrows of the domain. Right? If nothing has two things coming off of it, then you're good. Oh, you're right. Good catch. Thank you. I wasn't even paying attention. That's like that one from earlier. There are two negative 2's. So, yeah, that's not a function. That's kind of the same mistake that Ava made on the ordered pairs. I made the same one. So yeah, negative 2, I don't know what I'm getting if I push the button for negative 2. If it is a function, which is not, so we don't need to worry about that. Is it one-to-one? I don't even know what that says. All we're concerned about is it a function and is it one-to-one? And if it's not a function, it doesn't matter if it's one-to-one because it doesn't qualify. All right, now we're going to kind of cruise through some stuff here. Like all of this is right. These are different words for the x value. It's the independent variable is the x. If, then, cause, effect, domain, range. I would add input, output to this list. So just different ways of kind of phrasing x's and y's. But we're not really going to use that. Or at least, I'll phrase it this way. The ones that we will use, you already know. Like x and y, domain and range, maybe input, output. Discrete versus continuous, there are places where that's very important, but Algebra 2 is not one of those places, so we can just toss that out. Man, it's hard to read that. Again, all we're asking is it a function, and is it one-to-one? So y equals 0.5x minus 3. Okay, I don't have to be an expert at graphing this, but it would help if I know how to graph y equals mx plus b. All right, we begin at down 3. And the slope of 1/2, what's that mean? If the slope's 0.5.
It's 1/2.
Rise 1, run 2. Up 1 over 2, up 1 over 2. And again, this doesn't have to be perfect because we're only using that picture to figure out if it's a function and if it's one-to-one. So is it a function? Vertical line test. Function, yes, by the vertical line test. We didn't talk about the way to know if it's one-to-one. To know if it's one-to-one, it has to pass the horizontal line test. So that may be a new one, but it works the same way. Instead of a vertical line, you run a horizontal line, and it's the same test. If it hits twice, then the answer is no. If it hits only once, then it's a yes. So what do we think? Is this one one-to-one? Yes, by the horizontal line test. Do you know what shape 18 is? It's a parabola. Do you know which way it's going? Down. So I don't have to be perfect on this because all I'm really worried about is the vertical line test and the horizontal line test. So you know what? I'm not even going to put it on an axis. I know that it's a downward parabola. So is that a function? Yes. Because of the vertical line test. Is it one-to-one? No, it's a horizontal line test. It fails the horizontal line test. Right? Put a line right there. Crosses two places. So it is a function, but it's not one-to-one. You couldn't go backwards. If your output was whatever this y value is, you don't know what x value that came from. So functions in one-to-one. Function notation, should be familiar with that. F of x means whatever's in parentheses goes in for x on the other side. So f of 6 means plug in 6. It's like basic algebra review stuff here. So 12 minus 4 is 8. Okay, some practice with that. Let's skip 28. That looks easy. Let's do number 30 because it's a fraction. F of 2/3. So that means I'm going to make sure I use the f function. So that tells me which function to use. That's the name of the function. And the 2/3 is the input that I will use. So pardon the poor copy quality here. There's f. So in place of x, I'm going to put 2/3. So I grabbed my f function, I plugged in 2/3, and now 3 times 2/3, 3's cancel, 2 plus 2 is 4. I mean, I'm hoping this is like super easy. Like, I hope you're thinking like, what are we doing here? This is h at -2n. This is a little bit trickier because we're going to plug in not just a number, but an expression. But it's the same process. Let's grab the h function. And now in place of x, I'm going to put 2n, or -2n. So there's my h function, and then everywhere there was an x goes -2n. Right? That's what confuses people. Like plugging in a number, you've done that a million times, that's easy. Plugging in an expression, I mean, it's the same thing, it's just, it feels harder because it's not just a number, and so there's got a little more work to go here. What do I get if I square -2n? Good, 4n squared. Make sure you square everything on the inside, so 4n squared. And then -2 times -2 is +4. So -16n squared plus 4n plus 5. That next one's, well, they're all fuzzy, but we can cross that one out. All right, functions from a graph. This is easy, but man, some people mess this up. Even my calculus students mess this up, so it's worth spending time here. F of 1 means, what do I get if I plug in 1? If 1 is my x, if x equals 1, what is f at x equals 1? Now, I don't expect you to write all that. In fact, I hope you don't write all of that every time. But that's what your brain needs to think when you see f of 1. That means x is 1. So what is the y value at x equals 1? So somebody tell me, what's the y value at x equals 1 would be right there. So f of 1 is 1. So there's no computations, it's just understanding what's being asked. How about f of 0? It doesn't land at a nice spot, but Max, what do you think f of 0? That would work. -1.5. Again, if you looked at that and said that that was 1.6 or 1.7, that would be fine too. How about f of negative 2? I think that's an easier one.
2.
F of negative 2? Well, I see what maybe you're looking at,
Oh, wait.
but they give us a dot up there that I think lands on the grid. So what's f of negative 2? 4. How about f of 2? It's kind of a trick question. Here's x equals 2. What's my function at x equals 2? Well, it's an open circle, so it's not 5, right? Because we don't get to 5. I mean, the function's less than 5, but at 2, it's a trick question. There is no value there. It's undefined at x equals 2. And the same thing at negative 3. That one's a little more obvious because that's way off the graph. Thinking back to yesterday, is 4 in the range of f of x? Yep. In fact, it's in there twice. There and there. Is 4 in the domain of f of x? No, because that would be over here. Is 4 in the domain of f of x? Whoops, I did 3, but 4 would be the same problem, so no. Alright, finding domain from equations, that's important, but we'll do that later. Like, that's a little bit much for one lesson. So, okay, so here's the worksheet, but let's do a few of these together.
Sorry to interrupt.
Yeah, you can. He was expecting you. Let's see. So we said today the assignment is the odds. Monday's assignment is the evens. There are examples on here. I don't know that you need to work through the examples or maybe even look at them. This is just a selection of old Algebra 1 type things. So this should go quick, but we'll see. Let's maybe work one from each section. Let's see. 1, 2, or 3. I'm also trying to think, do you want me to work an odd or an even? You got to do them all eventually. Yes, that's why we split it up. So 19 today and 19 Monday. So that makes it not too bad. Plus, you start doing these and you realize they're kind of quick. Let's do number 1. Let's see. 8 times 4 squared divided by 8 minus 32. Let's see. 4 squared divided by 8 minus 32. Thinking about order of operations. So definitely want to do the parentheses before I worry about the 8. 4 squared is 16. Let's see. 16 divided by 8 is 2. 2 minus 32 is negative 30. And 8 times 3 is 24. With a 0 on the end of it. So negative 240. Let's see. Let's skip ahead to number 4. A, B over D, and they've given you what those are. So 8.2 times negative 3 over 1/2. Ooh, that's kind of yuck. Let's see, 8.2 times 3. 24.6, because 8 times 3 is 24. 3 times 0.2 is 0.6, so 24.6. Great if you could do that in your head. If not, you got to kind of come out to the side and do old school 8.2 times 3. 2 times 3 is 6. 8 times 3 is 24. There's one decimal. So yeah, 24.6. Fractions and decimals are kind of a pain, but how do we divide with fractions? Keep change flip, divide by or multiply by the reciprocal. So negative 24.6 times 2. And same thing. If you can do that in your head, great. If you need to sort of write it out, that's fine too.
Negative 49.
Let's see, 24 times 2 is 48. 0.6 times 2 is 1.2. So yeah, 49.2. With the oh, yep, you're right. You're right. Good catch. Thank you. Yeah, I could claim to make mistakes on purpose to see if you're paying attention, but I don't do that. I make enough mistakes on my own. So please pay attention and please call me out if I mess something up. Let's see. The rest of those are kind of the same thing. Just plug things in and see what you get. Let's see. Simplify each expression. Let's see. I guess let's do number 12. We got fractions and variables and all sorts of things. But simplify as opposed to solve, so that suggests that I'm not going to get a number answer. I'm probably not going to get x equals 12. I'm probably going to get something with j's and k's in it. So 1/5, let's see, 4j, be careful, minus 6j is negative 2j. And then 2k plus 3k is 5k. And then I can distribute the 1/5. So negative 2/5 j plus k. Again, this whole worksheet is just lots of little algebra stuff to hopefully get your brain back flowing in the algebra world. Let's jump ahead to number 20. Now we've got to solve. So that means I should get to an answer of x equals something. So simplify versus solve. I should get an answer here. What do you want to do first on number 20?
Add the n on the other side.
Let's add the n over. So 5/2 n plus n equals 98. Ooh, adding fractions, we did that yesterday. And of course, we still don't have calculators this unit, so we've got to be okay with, simple things like adding fractions. Common denominator, 2/2. So 7n/2 equals 98.
Oh, good. Not do.
Did I do that right?
Can I not do 7/2n, or is that not how it works?
No, that's fine. Yeah, if you want to write that as, and that might work better for what we're going to do next, like 7/2 n equals 98.
Right.
Yeah, that's the same thing.
All right.
And again, that might be better for what we want to do next. How do I undo the 7/2?
You got it.
Flip it.
Yeah, multiply by the flip, or multiply by 2/7. So we get n equals whatever 98 times 2/7 is. I'm hoping 98 divides by 7. That'd be nice. Yep, 14. So 14 times 2 is 28. Just your basic algebra skills. Let's do one more together. Yeah, let's do one more together. 26, although we've done one like this already. State the domain and range of each relation. Determine whether it's a function. If it's a function, is it one-to-one? So all those same questions we did a few minutes ago. Domain, range, is it a function? Is it one-to-one? So domain, that's easy to find. Range, easy to find. Let's back to the function thing. Is that one a function?
Nope.
Why not?
Because there's two 0.4s and different ones.
Yeah, that's a good answer. There's 2.4s and they have different y's, right? You got to make sure that they go to different things. So it's not a function, and if it's not a function, it can't be one-to-one, so that doesn't really even matter, that second question. Okay, so you've got 13 minutes left to work if you want to work some while you're here. Again, today's assignment is the odds. On Monday, we'll answer questions from the odds, maybe work a few more of the evens, and then you'll have time to work on it on Monday. So,
Whenever you turn in your packet on test day,